Hi, hello. I am Ajithkumar in APCSE. Today, see about our topic is a heuristic function inside of informed research. See, the informed methods add domain-specific information. They add domain-specific information to select the best path along which to continue searching. The heuristic function of h of n that estimates the coordinates of node n. Specifically, h of n is equal to estimated cost of minimal cost path from n to goal state. The heuristic function is an estimate based on domain-specific information that is computable from the current state description of how close we are to goal. Heuristics, all domain knowledge is used in searching encoded in the heuristic function of H. It is an example of weak method because of the limited that domain specific information is used to solve problem. See the examples, some of the problem 8 puzzle problem, then number of tiles are out of place, then sum of distance each tile is from its goal position. In generally of h of n is greater than or equal to 0 for all nodes is n. Then h of n equal to 0 implies that n is goal node. H of n equal to infinity implies that n is dead end from which a goal cannot be reached. Then see the weak versus strong methods. We can use the term weak methods to refer the methods that are extremely general and not tailored to a specific situation. See the example, means end analysis, space splitting, and subgoaling. Means end analysis is a strategy in which we are trying to represent the current situation and where we want to end up and then look for ways to shrink the differences between the two. It is a then next is splitting. It is a strategy in which we try to list the possible solution to a problem and then try to rule out classes of these possibilities. Then last is subgoaling. It has split a large problem into several smaller ones that can be solved at one time. It called weak methods because they do not take advantage of more powerful domain specific heuristics. The See the topic best first search in order nodes on the nodes list by increasing value of an evaluation function of f of n that incorporates domain specific information in some way. This is a generic way of referring to the class of informed methods. See the grid research. Use an evaluation of function f of n equal to h of n, sorting nodes by increasing values of f. Select node to expand believed to closed to a goal node. Not complete the node, then as it is an example of assuming all our cost are 1, then grid research will find goal G, which has a solution cost of 5, while optimal solution path a goal of I with the cost is equal to 3. Then next is another one is beam search. It is used an evaluation function f of n equal to h of n, but the maximum size of the nodes list is k. It is a fixed constant. It only keeps k best nodes as candidates for expansion and throws rest away. It is not completed. It is not admissible. The next algorithm A. The formula of algorithm A is f of n equal to g of n plus h of n. H of n means heuristic. Then g of n equal to minimal cost path from the start state to state n. The g of n term adds breadth first component to evaluation function. This is also not admissible. Then can be not completed h of n can equal infinity. See the algorithm A first step. These are all the steps in First node is open, then next is then open the node is empty. They exit with failure. If n is goal node, collect path back to start and stop, expand and generating all its successor and attach them pointer back. Then algorithm A star. A star search is H is admissible when H of n is less than equal to H of star n holes using an admissible heuristic grantees that the first solution found will be an optimal one. A star is completed whenever branching factor is finite and every operator is fixed for positive cost. It is admissible. Then some observation of A, perfect heuristic, null heuristic, better heuristic. Proof of optimally of A star search, we assume that A star has selected G2 goal state with suboptimal. We show that impossible. These are all the points. Dealing with the hard problem, for large problem A star often requires too much space. Two variation conserve memory, IDA and SMA. IDA is iterative deepening, deopening. The SMA is simplified memory bounded. Then what's a good heuristic? What is the good heuristic means? Relaxing the problem, combining of heuristics use. Then next is use statistical estimates to compute G. Then last is identify good future. Then use learning algorithm to find a heuristic function. Iterative improvement search. It is another approach to search involves starting with an initial guesses solution and gradually improving until is one. Some example hill climbing and simulated annealing, constant satisfaction. See the diagram of hill climbing on a surface of states. Height defined by evaluation function. See the current state is moves on the evaluation. See the exploring the landscape lacks local maxima, plateaus and the ridges. Drawbacks of hill climbing, problems, remedies, and remedies inside of a random restart and problem reformulation. Thank you.